Lesson 18 is the theoretical and empirical probability in social sciences, and this is the lesson 18 workbook. So theoretical probability is the probability of like what should happen, like kind of based on the odds, so if you have a coin, like you have a 50-50 chance of landing on heads versus tails. And then empirical, it's also known as experimental probability. It's like what are the outcomes if you actually conduct an experiment? So going back to the coin example, if you have a coin and you flip it 100 times, you're not necessarily going to get 50 heads and 50 tails. So whatever you do end up with, that would result in your experimental probability. So for theoretical probability, the formula is right here. So it's the number of favorable outcomes, like what you're looking for. So for example, if I'm looking to land on heads, it would be the one head out of the total number of possible outcomes. Heads and tails would be out of 2, for example. And then for experimental or empirical probability, the formula is on the right. It's the number of times the event occurred over the total number of observed occurrences. So back to the coin example, if I flip the coin 100 times, that would go in the denominator. That would be my total number of observed occurrences. And then if I'm trying to find the experimental or empirical probability of landing heads, I would put how many times they actually got heads in the numerator. So number 1, Brenda tosses 2 number cubes, so I guess 2 die with sides numbers 1 through 6. What is the probability that the sum of the numbers is 5? So this table on the right shows all of the possible outcomes of rolling 2 6-sided die just one time. So this top row represents that first die. You can either land a 1, a 2, a 3, or a 5, or a 6, 4, 5, or 6. And then this first column represents that second die. You can land on either 1 through 6. So all of these possible outcomes can happen just from rolling one time. You can get a 1 and a 1, a 3 and a 3, a 5 and a 2, and so on. So if we want to find, in this case, we're just going to find the theoretical probability of Brenda rolling 2 die that give her a sum of 5. So what is the probability that the sum of numbers is 5? If we look at this table, or if you just think about it, how can you roll a sum of 5 with 2 die? You can do a 1 and a 4 or a 3 and a 2. So you could do 1 and 4, but you can also kind of have the reverse of that, do a 4 and a 1, because those are 2 different outcomes because there's 2 different die. You can also do a 2 and a 3, a 3 and a 2. Again, those are 2 different outcomes because there's the 2 different die. And then those are the only other combinations, or those are the only combinations on the table that'll give you that sum of 5. So the rest of them will be either too high or too low. So theoretical probability is going to be the number of favorable outcomes. So how many possible outcomes are there where I roll a sum of 5? And there's 4 just based on the ones that we highlighted on the table. So that's this part of the formula right here. So total number of favorable outcomes, there's 4, because there's 4 spots on the table that have a sum of 5 over the total number of possible outcomes. So how many possible combinations can you get from those 2 die after just rolling them one time? And those are all of the outcomes on the table. So the table is 6 by 6, so it would be 36 possible outcomes. So the probability would be 4 out of 36, and then we just need to reduce it if we can, so both of these are divisible by 4. So we'll divide numerator and denominator by 4 to reduce, and it's going to give us a 1 out of 9. So there's a 1/9 probability that the sum of the numbers that she rolls is going to be 5. So probability is 1/9. And then number 2, Mr. Hammond's art class consists of 5 sophomores, 4 juniors, and 9 seniors. They randomly select one student from each class session to select the music played during class. The grade of the student that was picked for the first 8 class sessions, I can't read right now. The grade of the student that was picked for the first 8 class sessions is shown in the table. Which statement is true about the theoretical and empirical probability of selecting a sophomore? So theoretical, remember, that's what's supposed to happen. So the theoretical is based on how many kids, what is the assortment of students in the class, of grades in the class. And then empirical is experimental, so it's what actually happens once you go to conduct an experiment. So empirical would come from the table. So theoretical is going to come from the breakdown, what are just the general possible outcomes, and then empirical comes from actually like conducting an experiment. So all of the answer choices are just kind of like asking us to compare, like, are they the same? Are they different? Is one larger? Is one smaller? So we'll just find both of them. So for theoretical, I'm just going to shorten it to T. And we're supposed to be finding the like probability of selecting a sophomore specifically. So for theoretical, the probability, I'm going to say probability of sophomore. That's the way we write probability a lot. Probability a lot of the time is like P for probability, and then of what you're trying to find the probability of goes in the parentheses. So for theoretical, we need to look at the breakdown, which there were 5 sophomores. So it'll be 5. That's like our favorable outcomes. So 5 out of the total possible outcomes. So to find that, we need to like figure out how many kids are in the class. So 5 plus 4 is 9, plus 9 again is 18. So 5 out of 18 is our probability, our theoretical probability of selecting a sophomore. And then for empirical, that's like what actually happens once they go through the first 8 class sessions. So probability, and we would write it the same way, but probability of selecting a sophomore. So for this one, I look at the table. I want to see how many sophomores were selected from that table. So 1, 2. For our favorable outcomes of sophomores out of like the total amount of experiments in this case. So there was 8 class sessions. So these are 8 like experiments or times that we checked it. So it'd be 2 out of 8. And then 2 out of 8 we can reduce down. That would be like 1/4. And if you're ever like having a hard time comparing like fraction probabilities to see which one's larger, just turn them into decimals. So to turn fraction into a decimal, you do numerator divided by denominator. So 5 divided by 18, that's about, like if I were to round to the nearest whole number, it would be about 28%. I guess I said I was going to do a decimal, not a percent, but about 0.28 or 28%. It's the same thing. And then 1/4 is 0.25. So sometimes seeing it like that makes it a little bit easier to compare those numbers. So we figured out that like the theoretical was larger than the empirical, or the empirical is smaller than the theoretical. So if we look at answer choice A, it looks like. So the theoretical probability is greater than the empirical probability because the theoretical that we got was 0.28, which is larger than 0.25. All right, and then number 3, I'm actually gonna, before I go down to number 3, so of course, like if we look at B, you know, it says they're equal, so that's not true. And C says theoretical is less than empirical, which is not true either. But D says they can never be the same, and that's not true. They totally can be the same, just kind of based on how the outcomes happen. So something like this, like, may be kind of hard to determine at first, but they absolutely can be the same. All right, number 3, Zola has a spinner that's divided into 4 equal sections. Each section is labeled with a number 3, 5, 7, or 9. He conducts an experiment by spinning the spinner on a slanted desk surface. The table shows the results of 40 spins. How does the theoretical probability the spinner lands on a number less than 8 compared to the empirical probability of that happening? So you don't have to, but it might be helpful to draw a picture to see the probabilities, the theoretical probabilities. It's really up to you. But kind of the same thing as last time, where our theoretical probability is going to come down to like what should happen based on the odds. And then our empirical probability is going to come down to like what actually happened on this experiment. So if you can tell the odds without a picture, which I'll kind of talk about how in a sec, that's totally fine. But if you like imagine a spinner, it has 4 equal parts. And in this case, we're trying to find like the probability that that the spinner lands on a number less than 8. So of our 4 numbers that'll be on this spinner, 3 of them would be less than 8. So like if we were trying to find our theoretical probability, I'm going to say probability of less than 8. There's 3 possible outcomes that are less than 8. So those are favorable outcomes out of 4 total possibilities on the spinner. So that would be 3/4 or 0.75. And then if it's hard to tell just from the list, just like I said, draw yourself a picture. So it says it's a spinner. It has 4 equal sized sections. And one is a 3, one is a 5, one is a 7, and one is a 9. And we're trying to find, like I said, the probability that lands on a number that's less than 8. So it could be 3, 5, or 7. And so that means the favorable outcomes, there's 3 of them. Out of the total amount of outcomes on the spinner, there's 4 of them. So 3 out of 4. And then for our empirical, it's based on what happens in the table. So probability that we end up with something that is less than 8. So we want to figure out how many favorable outcomes we have. That's going to go in the numerator over how many total possible outcomes there are. And the total possible outcomes, they told us in the problem, it says the table shows the results of 40 spins right here. So we don't even really have to count up necessarily all the spins. You definitely can. It should end up being 40. But that's going to be our total amount of outcomes. It's how many, or total amount of experiments, because how many times you spin the spinner. And then for the numerator, our favorable outcomes. And when I say I'm referring to these formulas up here, I just haven't been scrolled back and forth. So right now with empirical, the total number of observed occurrences, that was the 40 spins. And right now we're trying to find the number of times the event occurred. So in this case, the event is landing on something less than 8. So for the numbers we're looking at for less than 8, it would be a 3, 5, or 7 again. So here's all the frequencies. So that's how many times that we're landing on each of those. So we just have to add them all. So 8 plus 9 is 17, plus 13 is 30. So we land on a number that was less than 8 30 times out of 40 possible spins. So 30 out of 40, that reduces down to 3/4, just like the other one. And then 3/4 is 0.75. So I guess this one we didn't really need to convert to a decimal because we ended up with the same fraction. But either way, so we ended up with the same exact thing. And so it looks like that's the answer choice D. And kind of going back to number 2 where it said it can never be the same. They can certainly always end up being the same. It's just kind of by chance. So in this case, theoretical and empirical probability ended up being identical, 3/4 or about 70, or not about, exactly 75%.